Alright, hey guys, welcome to a video. We're going to be discussing the tropical weather in the Atlantic and the Northwest Pacific, in the Northeast Pacific Ocean, otherwise just known as the East Pac for shorthand. We will not be discussing the Northwest Pacific yet. We might do that in a future video. Currently in the Atlantic, there are no tropical cyclones right now that are currently expected. Yeah, actually zoom out so we can actually use the pen. There are no tropical cyclones expected within the next 40 hours or within the next 7 days. That's mainly due to the fact that the majority of tropical waves that are coming off of the coast of Africa are coming off too far to the north, and they're getting dry air that's becoming entrained from both dust that's coming off the Sahara and mid-latitude dry air that's coming down. So tropical waves that do move off are getting cut off by dry air. But as we move closer to September, the intertropical convergence zone and the monsoon trough should begin to break down and move south, allowing these storms to begin developing and actually start moving westward over time. We just had Ernesto that was up here. It's impacting Europe right now, specifically the British Isles. It was a tropical cyclone that impacted the northeast Caribbean and then moved up, impacted Bermuda almost head on. I'm not quite sure if there was a landfall. It made its second peak here as it passed around where the Gulf Stream is, and then it moved north and out like this. So overall, for the entire year, we've had 5 named storms, we've had 3 hurricanes, and we have 1 major hurricane being Beryl back in June and July. And almost all the storms have been pretty long-lived, and every single one has impacted land in some fashion. So we're currently sitting around 55 ace, where normally for this time of year we'd be closer to about 20. Now, in the Eastern Pacific, we have a different story. It's not quite the same as in the Atlantic where it's quiet right now. In the Eastern Pacific, we have two tropical disturbances that are both very likely to develop within the next 7 days. This wave behind Gilma will probably not develop within the next 2 days, but will most likely develop as the week progresses. And then this wave in front of Gilma is going to be a threat for the Hawaiian Islands later this week. Gilma right now is an actual tropical system that's been classified as a tropical cyclone and now has winds of about 105 miles per hour, according to the National Hurricane Center, with a minimum pressure around 972 millibars within the center of the storm. This storm is rapidly intensifying right now. It was a tropical storm, I believe, yesterday, but its structure has vastly improved, so it now has a clear eye that popped out within the span of about 3 hours. So the storm is rapidly intensifying and should become a major hurricane very soon. If we were to click on it. So yeah, very soon, possibly within the next 6 hours, most likely. Within the next 6 hours, Gilma will most likely be a major hurricane for the next 2 days. It can get up to potentially a Category 4 hurricane out here, maybe stronger if conditions are right. And then as it moves further west, it will begin weakening, but still will be a hurricane by the time we approach next Monday, which is roughly 5 days from now. If we're going to look for at least like a forecast discussion, which is up here, Gilma satellite presentation has improved significantly over the past 3 hours as clear eyes that appeared in visible imagery, and the latest subjective Dvorak intensity estimates from TAF-B and SAB were both T 5.0, 90 knots. Using these estimates, Gilma's initial intensity is set to 90 knots for this advisory, which represents an increase of 30 knots over the past 24 hours, meeting the criteria of rapid intensification. The storm is moving west-northwest and is still improving its inner core and circulation. So I did mention a Cat 4 is possible within the next 24 hours. It could be stronger than this, but we really have to see. It was really going to depend on how the dry air affects it and the sea surface temperatures underneath it. As the Eastern Pacific is not as warm as the Atlantic, but you only really need 20, 28 Celsius waters. I think 27.5 and higher to support major hurricanes. Now we're expanding out to global tropics hazards overall for the next 2 weeks. So not the week that we're in right now, but next week and the week after that. So you get into September. For the Atlantic, it looks to be around the end of August into the beginning of September. There's a very high chance that a tropical cyclone does develop in the tropical Atlantic off the coast of Africa before it reaches the Caribbean islands or just north of that. A very high chance of around 60% of a tropical depression or greater. And that chance continues later into the month with a little bit less certainty. This below average precipitation up here indicates that there's a bit of high pressure ridging. So if this were to hold true, this would mean whatever tropical wave does develop within this area is most likely going to be guided west right into land masses, and that will give it the ability to take advantage of very warm waters that are pretty much untapped in this part of the basin. A little bit tapped by Ernesto, but most of that is up here where this reduced rainfall precipitation chances. You can also see a general, at least for tropical waves in general, there's more precipitation within the Caribbean and Bay of Campeche. In the Eastern Pacific, it really dries out next week. We're expecting the basin to shut down, it seems. And the Western Pacific has a 20% chance of having a tropical cyclone in the western part of the basin around that time as well, which really increases as we get to September, into the middle of September, with a much higher chance around the Philippine Sea. As you can see, the rainfall amounts start increasing. Now, the Pacific also has a small chance around September 4th to 10th, but the Atlantic should overshadow that, as the Atlantic will have a more favorable atmospheric setup, with the MJO inducing a form of sinking air over the Eastern Pacific and a little bit of Western Atlantic, allowing the air to rise over Africa, which is where the tropical waves that form into tropical cyclones in the Atlantic most often come from, besides mid-latitude systems. And that should allow the Atlantic to really blossom as we get into September. Another thing to keep in mind is that right now there's a little bit of shear impacting some waves that are coming off of Africa. Plus, the tropical waves are moving quite quickly as they're moving off the coast. But in general, as we move into the time frame of the 28th, into the 29th, into that 2-week period, you can see a large amount of the Atlantic Ocean, at least in the upper levels, has this upper level anticyclone above it, which means that the air is going to be diverging at the upper levels, allowing tropical cyclones to converge air more easily at the surface and bring that up to build the storms up. There will also not be much wind shear, as in the case up here, that can disrupt any tropical cyclone. We can also see, at least from this outlook, we can also see you have some troughing coming off the United States, which is quite persistent. It's been quite persistent for a while now. So that may have a weakness in this part of the ridge. But if any storm does get going, this ridge here, especially if we change this to upper dynamics around 500 height, you'll see we have a large ridge here that is in the center of the Atlantic, right where the below average precipitation was. And that should keep any tropical wave that does form to the south, but there is a little bit of breaking a little bit far out, and then the ridge starts rebuilding back in later. But that's a little bit too far out. But just so you guys know, we do have ridging over the central Atlantic. So if a tropical wave were to get going now, it will be going straight west or slightly northwest. And then depending on the given steering currents where it ends up. Let's say if it ends up here or if it ends up in the Caribbean, that will dictate what paths are available. Not that type of path. What paths are available to the storms at any given moment. Right? Now, sea surface temperatures. We're going to look at this. This large cut in the sea surface temperature profile of rapid cooling in the western Atlantic around where Bermuda is due to Ernesto passing through this area recently. So cooler water from the depths has upwelled in Ernesto's wake. So that area will be temporarily cooler for now. And won't be as able to support a tropical cyclone as just a week ago before Ernesto came through. However, in the Caribbean and just west of that, like in the Gulf and in the Caribbean, there's still a general warming trend of the waters here. The Northeast Gulf has cooled down a little bit from cooler air over the eastern United States. However, the warming of the Southern Gulf and the Caribbean will add a little bit more fuel to any storm that does come through the basin later on. So if a storm doesn't get going now, that will just leave more energy for the next storm to get in this area. And because we're not having too many waste storms in the subtropical Atlantic this year, that should focus the majority of the energy into the tropical Atlantic down here and create storms that will be long lasting and potentially intense depending on where they develop. From a sea surface temperature phenomenon, at least for the Atlantic, the 26 degrees Celsius isotherm is roughly right in through here. I'm going to try and trace it the best I can. It's roughly right in through there. And the 30 degrees Celsius isotherm, it's a little bit too big. The 30 degrees Celsius isotherm is in the Northwest Caribbean, the Bahamas, and almost all the Gulf of Mexico. The Gulf of Mexico right now has record heat content if we take all the positions of the Gulf and average it out. So what that means, and we'll refer to this tweet, 2024 so far, this is from August 19th, the Gulf of Mexico's ocean heat content is way above where it should be for this time of year. So what that means is that any storm that does get in the Gulf will not really upwell any cool water that could disrupt the system or leave a cold wake, as Ernesto did. So the Gulf could support major hurricanes back to back in this sort of setup, and any storm that does stay there for a decent amount of time and has the correct environmental conditions like low wind shear, a humid atmosphere around it, and a decent structure so it can actually take advantage of the good conditions, will allow any storm that gets into the Gulf to potentially become very intense or rapidly intensify as it's coming up to landfall. So this is bad news if we do get a storm in here. If we don't get a storm in here, it's still bad news for the heat reasons and how it affects fisheries. But in the case of hurricane season, if a storm does get into the Gulf of Mexico with temperatures of 30 Celsius or higher, I believe I have it up here, with 30 Celsius or higher and a large area of 31 Celsius, especially closer to Louisiana and in the North and Central Gulf of Mexico, that will allow any storm that does get in here later, let's say a potential, I'll draw on like an Ida track, any storm that does this, for example, will have plenty of warm water to take advantage of. And this will probably be a 2-day trek. So any storm that does get in the Gulf will have the heat energy with it. It just needs the right atmosphere and the right moisture in the right amount of moisture to be able to do this. And it's looking, as we get into September, most of the basins should be favorable. So it's very possible that we see a decent amount of major hurricane impacts as we get closer to the peak of the season. Off the U.S. East Coast, The warming should be slowing down now as we're heading into September, and also we have a cooler air mass that's over the eastern United States. So the water temperatures that you see here might get knocked down a little bit, especially further north. Not so much off the Carolina coast. But the 29 degrees Celsius isotherm peaks up to about there, which is the Gulf Stream, and then 28, which I'll highlight with blue, is roughly here. So any tropical cyclone that can get up here, as long as it has decent conditions, will do pretty well. The water off the southeast coast is also warm. However, the caveat here is that the water off the southeastern United States is shelf water, and that doesn't extend as far down as in the Gulf. So any major storm that does come through this area is going to take a sizable chunk out. So the water temperatures here may look like 29, 28 on the surface, but if we go down tens of meters and we have a stiff wind that's moving across this shelf water, you're more likely, if the storm is not moving too quickly, you're more likely to have this drop quickly to around 27 or below. Whereas if it stays over the Gulf Stream for longer, it won't have that problem. Any storm won't have that problem. But we're pretty much at the peak of where sea surface temperature should be. And then as we get into September, we should continue going down, 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 especially up here in the northeast. They should begin going down very shortly as cold fronts bring in cool air from Canada, and that's going to upwell some coastal water and also cool it down via cold air advection. So, what else are we looking at besides that? Well, a look into the future would be stuff like the MGO and this potential velocity graph, Hofmüller diagram, where time goes from earliest to the future down here, and then gray zones are sinking air, and then green zones are rising air, and these are Kelvin waves, MJO, stuff like this. Currently, we are in a position where the Eastern Pacific, minus like some MJO waves, I think these are sinking, the Eastern Pacific is benefiting right now from a favorable MJO position with rising air over the Atlantic, boosting the Eastern Pacific's ability to generate tropical cyclones. However, as we go down in time, the rising air moves over Africa in the Indian Ocean. And if we know anything about that, I'll draw a simple graph here. Rising air, at least in the MJO, has two directions. It has the westward component at the upper levels and the eastern component. Right now, the Eastern Pacific is in the western component of this graph. So, what's happening is, at the surface there are weaker trade winds, and at the upper levels there are weaker easterly jet winds from the mid latitudes. So this means that there's less wind shear, and there's also more moisture that's left over from the rising phase of the MGO that just passed through. So tropical cyclones are really going to like. I'll put the X here. Tropical cyclones are really liking this environment. But as time goes on, the Eastern Pacific is going to have more sinking air directly on top of it. And sinking air is going to start spreading into the western portion of the Atlantic. So, this will shut down the tropical waves that are coming across, that are forming into the tropical cyclones that are there right now. But as a consequence of that, the rising air moves over Africa. So because that's where the majority of tropical waves in the Atlantic begin, That will help send more tropical waves into the Atlantic, where the water is very warm across the entire basin. So, even record warm in many places, where the Caribbean and Gulf are running 1 to 2 degrees Celsius above normal, or about 2 to 4 degrees Fahrenheit. So any storm that does get into that environment with that weaker wind shear, with the less trade winds with weaker trade winds at the lower parts of the atmosphere, so the storm isn't going to be moving too fast, and trade winds aren't going to be stirring up the ocean as much. That will allow the ocean to warm up a bit more, and will give tropical cyclones the conditions that they need to really develop in the Atlantic in the near future. Now, from a model perspective, we'll go back here and we'll talk about the storm that's going to be impacting Hawaii, and then we'll end the video. If I can find it. Okay. Scroll back. We'll use precipitation for the GFS, and we'll look at this system. I believe, if I go back here, let me go back to the home menu. And let me find the name. This will be Invest 91E. So we'll go back. So Invest 91E is currently positioned east of Hawaii, and it's this tropical wave right here. As we progress that in time, within a day's time, it begins organizing more. We start seeing more convection and more heavy rain around the center, and the pressure is beginning to fall. As we're going another day out, 48 hours, it starts intensifying more, and we're getting the banding features that are common in tropical cyclones. So we have this feeder band coming off the monsoon trough, and then we have this circulation on the north side as it wraps into its low pressure system, and the pressure begins falling more. And then moves westward. Time goes on. This is Gilma on the right. It intensifies slowly on day 3, which would be, I believe August 24th. I can't remember what today is. I believe that's Saturday. So on Saturday, it's approaching the Big Island. You're gonna start feeling swells on the ocean from the ocean before us. So you're gonna have an increased chance of rip currents in the Hawaiian Islands for the rest, starting soon, and then for the rest of the week as the storm approaches. And then as the storm comes by on day 4, it's getting closer to the Big Island, looking at a strong tropical storm, the Cat 1 hurricane, at least according to the GFS model. And then the storm weakens a little bit, but it moves a little south of the Big Island. However, the onshore flow is pushing water directly onto the island, and because the Hawaiian Islands are mountainous, this means that there will be a ton of heavy rainfall on the Big Island of Hawaii. So that will mean potential for flooding, in addition to the large waves and some potential storm surge. Although because the water around Hawaii is pretty deep, the waves are going to be much more of a problem than storm surge will be. And then, as you take this out the full 5 days out, it begins really disintegrating as it passes through the Hawaiian Islands. And then you have more rain that just keeps wrapping onto the islands from the right side of the storm as it weakens and dissipates. And by about a week from now, next Wednesday, it's fairly weakened. And then you have Gilma coming in behind that, and then the next storm behind Gilma. But this is too far out. But we'll be definitely watching what comes behind 91. We'll see if Gilma becomes a threat for Hawaii, and we'll also see what the storm behind Gilma does, as that looks to be going out into the open Pacific, where there's cooler water up here, but that could maybe influence another storm further back east. If we look at the ECMWF model, just the Euro model, skip to this. See, 91 is still right here. I don't think you guys can see my cursor, but 91E is still right here. and it's generally moving in this direction still. So then, as we keep going, 91E begins developing a bit slower than on the GFS. So by Friday, it's still like a tropical storm, tropical depression, and it's still slowly moving towards the island. It doesn't get as strong as on the GFS. However, you still see the heavy rainfall threat that's impacting the big island of Hawaii, as the onshore flow hits the elevation of the mountains and really forces all that rain out. So I definitely think that flooding could be a big issue for Hawaii, for the big island of Hawaii, and maybe the other islands as well, depending on how it interacts with its topography. And then the Euro model takes the future 91. I don't know the exact name of the storm, but it takes it into, I believe that's Maui, that takes it into western Hawaii, and then finally disintegrates it. It doesn't weaken the storm as much as the GFS does in this area. The GFS has the storm weakening as it turns north. The Euro model has the storm strengthening a little bit, and then slowly weakening as it goes up towards western Hawaii. So we still have to pay attention to this. This is still like 5 days out, but Hawaii should definitely prepare for a tropical cyclone impact of a tropical storm to Category 1 hurricane in the next 5 days. So make sure you guys get your preparations ready for that one. And we'll also look at a hurricane model. We'll look at the HAFS A parent, and we'll look at Invest 91E from a sea surface temperature perspective, because we already kind of know the intensity. Okay, so we're gonna go back to this, and we're gonna show where it is now. 91E currently is sitting over water temperatures of about 28 to 27 degrees Celsius. So modest strengthening should occur, but it really depends how much of this cool water interferes with the storm circulation, and also how much the Big Island of Hawaii interferes with the storm circulation as it tries to turn north again. As on the western side of Hawaii, there is more warm water to take advantage of as it moves west. We'll also look at shear, 200 millibar shear. Currently, it seems that the storm has a decent shear outlook, although shear north of the Hawaiian Islands might affect as it begins moving north in the 5-day time frame. But wind shear should not really be too much of a problem. The storm should have very good ventilation, but the sea surface temperatures are not as high as they could be to support a very intense storm, so strengthening should be rather slow. And we'll also look at moisture and humidity as well before we wrap it up. From a moisture perspective, it seems that 91E wraps around. Right now, it has a poor moisture outlook, but as it strengthens, it begins to consolidate its core and gains more moisture around it, so it becomes solidly locked off from the dry air that's trying to get entrained into the circulation. It's what it seems like. And then if we keep going out into time, the storm only gets more defined, and is able to keep that dry air out of its east side, but a little bit of dry air keeps trying to get in on its west side, so that might be impeding the storm's intensity. While on the east side of the storm, a lot of this heavy moisture is pummeling right into the Big Island of Hawaii, so that's another reason to worry about the heavy rainfall rates that will be impacting the island. And then once it passes the Big Island of Hawaii, Hawaii will still be on the eastern side of the storm, so they'll still be having the strong winds, the tropical storm force winds. They'll still be having a decent amount of rainfall, especially in the mountainous areas. And they'll still be having the swells and the large waves from this storm. And then, as 91 moves west of Hawaii, dry air starts to become more of a problem for it, and it begins weakening more. Weakening more. So we have more dry air that's on the left side of this system, the western end of the system. So we have more dry air that's getting entrained into circulation. So this might be a big reason why the GFS has it weakening here. But the Euro might see that the storm is able to hold against the dry air more and take more advantage of the sea surface temperatures underneath. So it doesn't weaken as much until it gets closer to the Hawaii proper. But yeah, that's all I would like to say to you guys. I hope you guys found this video to be informative. We talked about 901E. We talked about Gilma. We talked about Gilma in the Eastern Pacific. We talked a little bit about why the Eastern Pacific is active, and what to look forward to in the Atlantic as conditions get more favorable as we head into September. Alright, I hope you guys learned a lot from this video. I'll try and make another video regarding other topics, and I'll try and make more videos pertaining to meteorology in the future. Specifically tropical weather, as this is the stuff that I tend to look at the most. Alright, I hope everyone has a good day. Take care.